lots of equations, some using one step, some using two steps, some using more than two steps, and some where there were variables on both sides. Today, we'll talk about how to solve equations that have absolute value in them. So first, I want to make sure you understand what absolute value means. So absolute value is the distance a number is from zero. So the absolute value is saying how far is that number from zero. And since the absolute value measures distance, the result is always positive. I've talked before about how you have the commute from your house to school and from school to your house. Now you could say those are traveling different directions, obviously. One might be east, one might be west, or north or south, or whatever. But you're still traveling a positive distance no matter which direction you travel. So if you look at this number line below, if we wanted to know the absolute value of -3 and +3, both of them have an absolute value of 3 because both of them are 3 units away from 0. To get from 0 to -3, I have to go 1, 2, 3 steps. To get from 0 to 3, I go 1, 2, 3 steps. So that means the absolute value of 3, which this is the way it's written, two straight lines that are a little bigger than the number. It doesn't do great on this with this font, but the point is it should be a little bigger than the number when you draw it. Absolute value of 3 is 3 because it's 3 units away from 0. The absolute value of -3 is also 3 because it's also 3 units from 0. Ergo is another word for therefore. Might be Latin, honestly I forgot at the moment, but ergo just means therefore. So the absolute value of -5 and +5 is 5, because both of them are 5 units from 0. The absolute value of 8 and -8 is 8, because they're both 8 units away from 0. The absolute value of 33 and -33 is 33, because they're both 33 units away from 0. The absolute value of -14 and +14 is 14. Absolute value of -3 halves and +3 halves is 3 halves. And the absolute value of 6.7 and -6.7 is 6.7. So I did those last two to make sure you knew this works not just for whole numbers and integers, but also for fractions and decimals. And really, when you're evaluating a number, it is truly this simple. There's not any more tricks coming when you're only asked to evaluate it. So when evaluating numbers inside absolute value bars, those straight lines right there, you must first simplify the numbers completely, then apply the absolute value to it. Do not apply the absolute value until after you have simplified the inside completely. Now, simplifying the inside will make sense on these examples right here. So I'll talk through these steps, it goes this way, as I do the problems. So this says evaluate each expression if r equals -3, n equals -2, and t equals 3. So on this first example, I just need to plug in t. They said t equals 3. So what it was saying about simplifying everything inside completely, we need to go ahead and do the subtraction. 7 minus 3 is 4. Then, now that we've simplified what's inside, we can apply the absolute value. The absolute value of 4 is 4. And 4 plus 4 is 8. So we plugged in the value. We plugged in 3. We simplified within 7 minus 3 is 4. We took the absolute value of that, which is +4. Then we simplified the expression, meaning we added 4 and 4 together. So we'll do the same steps for number 2. We'll first plug in the value. R is -3. Next, we need to simplify what's inside the absolute value. So 2 times -3 is -6. -6 plus 4 is -2. Then we do step C. Take the absolute value. The absolute value of negative 2 is positive 2. And 2 minus 3 is negative 1. So notice the final answer may in fact be a negative. An absolute value can never result in a negative. But once you have other things happening after the absolute value, it could turn out negative. Okay, number 3, we plug in the value. N is negative 2. So next we'll simplify within the absolute value bars. This minus a negative we can change to plus a positive. 4 plus 2 is 6. The absolute value of 6 is 6. 5 plus 6 is 11. Okay, now the reason it says plug in the values is because sometimes, like in number 4, you'll have to plug in more than one number. Here we've got to plug in for n, which is negative 2, and t, which is 3. 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. The absolute value of negative 1 is positive 1. Okay, last up, number 5, it says 9 minus the absolute value of 3. N is negative 2, and R is negative 3. So we got lots of work to do on the inside here before we can take the absolute value. So 3 times negative 2 is negative 6. Negative 6 plus negative 3 is negative 9. Now we cannot do minus a negative means plus a positive here. That will not give us the correct answer because we cannot do anything with stuff outside the absolute value until we've taken the absolute value. So the absolute value of negative 9 is positive 9. So we get 9 minus 9, which is 0. But you may have noticed we have evaluated absolute values, but we haven't solved an equation with one yet. So here we go. All right. So this is what makes absolute value solutions very different. When you're solving equations that involve absolute value, unless there's no solution, which we'll talk about that when we get there are always two solutions. Now there's an exception, like I said before, there could be no solution, but if it's not no solution, then there are two solutions. That's because both negative 5 and positive 5 have the same absolute value. This means if we're asked to find the solutions to the absolute value of x plus 4 equals 1, it's possible x plus 4 is 1 because the absolute value of 1 is 1. It's also possible that, that should be an x right there. It's also possible that x plus 4 is negative 1 because the absolute value of negative 1 is 1, so that would also work. So what that tells us is the absolute value equation has no solution if it's set equal to a negative number. So this is where the no solution is coming in, right here. We'll have no solution if the value is equal to a negative number. So right here, we know this cannot be true because there's no way an absolute value can ever equal a negative number. It can equal 0 or any positive number, but it can never ever equal a negative number. Same here. Absolute value of this equals negative 4. That cannot be true. So both of these have no solution. And you can write those words, or you can use that 0 with a slash through it to say no solution. But I'll go ahead and tell you, all 5 of these we're going to do have two solutions. So here's how we set it up. This is true for all the ones where we're solving equations for absolute value. So y has two possibilities. What's inside this absolute value could be equal to exactly what it says, 5, or it could be equal to negative of that, which is negative 5. And on this one, we don't have to do any work because it's already y equals. So then we have to, I have it on here, we have to mark it at negative 5 and positive 5. And then we do a closed dot on negative 5 and positive 5. Because we know positive 5 is an answer, and negative 5 is also an answer. Okay, as we look at number 7, we know there's two possibilities. It could be that n minus 4 equals 4, which is exactly what this says, but it's also possible that n minus 4 equals negative 4. Because if we took the absolute value of negative 4, that would be 4. So notice, I'm not saying the absolute value of n minus 4 could equal negative 4. I'm saying just the inside part by itself, n minus 4, could equal negative 4. Because if these two things are true, then we'd be saying, oh, well, the absolute value of 4 equals 4. That goes with this one. Or the absolute value of negative 4 equals 4. That goes with this one. Now that we've set these two scenarios up, we add 4 to both sides. We get n equals 8 as one possibility. Add 4 to this side and this side. We get 0, so 0 is the other possibility. So the two correct answers for this are 0 and 8. So let's go back here and look for a second. If I plug in 8, I get 8 minus 4, which is positive 4. The absolute value of 4 is 4, so that works. If I plug in 0, 0 minus 4 is negative 4, and the absolute value of negative 4 is 4, so that one also works. Same process on number 8. We just remove the absolute value bars, set it equal to what's there. Remove the absolute value bars, set it equal to the negative version of what's there. So we'll subtract 3 from both sides to solve this one. We get x equals negative 1. Subtract 3 from both sides on this one. We get x equals negative 5. Okay, number 9, we'll say, well, it's possible that 2x equals 8. It's possible that 2x equals negative 8. Divide both sides by 2. We get x equals positive 4 here. Divide both sides by 2. We get x, oh wait, sorry, I forgot a negative here. My fault. So the setup is 2x equals 8, 2x equals negative 8. So this one would give us a negative 4. So our answer is both 4 and negative 4. Both of those are solutions to this equation. Okay, truly last one. The rest on this page will actually be used for another lesson at a different time. So we first set up 5y minus 2 equals 7. Then we set up 5y minus 2 equals negative 7. So we'll add 2 to both sides, getting 5y equals 9. Divide 5 on both sides, giving us y equals 9/5. You may be like, oh no, Mr. Lin, how could you possibly give us things that aren't whole numbers? I know. Well, if you get something that's not a whole number, all I ask is that you put the dot in between the two whole numbers that's between. So here's what I mean. You don't have to convert this to a mixed number. You might be able to see already. But if you convert it to a mixed number, you can say, okay, 5 goes into 9 one time. And if we take 5 away from 9, that's 4. So we'd have 4/5 left. So that means it's bigger than 1 because it's 1 plus 4/5, but it's smaller than 2. So I don't care where you put it between 1 and 2. Just put a dot between 1 and 2, and I'll give you credit for that. Now this one we add 2 to both sides. Get 5y equals negative 5. We divide both sides by 5, and we get y equals negative 1. So our other answer is negative 1. So our two numerical answers are 9/5 or 1.8 or 1 4/5 and negative 1. You can see in the graph here on the line.